Alright, we're going to work on zeros of a function, but this time, instead of being asked where if an input is a zero of a function, we're going to actually solve for the zeros of a function. And that is very easy to do when a function is in factored form. This function is in factored form because each of the pieces of the function, each of these binomials, is being multiplied by the next one. I have multiplication going on here between this first binomial and between these second two binomials. So it's like I have three pieces of this function, a times b times c. And if I want the function to be equal to 0, then any one of these pieces could be equal to 0 themselves, and it would zero out the other two. For instance, let's say the first part was equal to 5, and the second part was equal to 3. 5 times 3 times what makes 0? Then if the third part's equal to 0, the whole thing would equal 0. Likewise, a could be 0 and b and c could be some other number, and the whole thing would zero out. And the same goes for b. It could be 0, a and c could be some other numbers, and the whole thing would zero out. Or all three pieces could equal 0. So when we're solving a function that's in factored form for when it equals 0, let's write this out. We've got x minus 2 to the third power times x plus 4 times 3x minus 2, and we want it to be equal to 0. All I have to do is identify those factored pieces and then write each one out as a little mini equation set equal to 0. Either this piece needs to equal 0 or this piece needs to equal 0, or this piece needs to equal 0. I didn't need the parentheses around that, so don't worry about that. You don't need the parentheses. And then we go about solving each of these little mini pieces. So this one I can just see the answer. I know that when I put a 2 here, 2 minus 2 is 0, but you can show the steps if you want for consistency. So when I put a 2 into the function right here, 2 minus 2 is 0, 0 cubed is 0, and 0 times whatever these two pieces are will give us the result of 0. Alright, the next little piece that I really didn't need the parentheses on, when I subtract 4 from both sides, I get x equals negative 4. And again, you can just see that answer. What do I put here to get 0? A negative 4. And when I go back up to the function, putting a negative 4 here makes the middle piece 0, and times whatever the other two are will give us a final result of 0. The last little function, a little mini factorable piece, needs a bit more solving. I need to add 2 to both sides, bring down 3x equals 2, divide both sides by 3, and I get x equals 2/3. So putting 2/3 here in the function, timesing that by 3, I get 2. 2 minus 2 is 0, and again it will zero out the rest of the function. Alright, I'm going to give you another one to try. And let's see what that one's going to look like. I'll give you that one in the next video.